Welcome dear students to our YouTube channel lectures. So in the last video I gave the information or the definition of Euclidean algorithm. In this lecture we are going to see that how to apply this algorithm or procedure to compute GCD of two positive integers. So generally we can consider minimum two positive integers. The question will be like this: find the GCD, greatest common divisor, as I mentioned earlier, of 18 and 76. 762 we can take 762 by using or applying Euclidean algorithm. It is simply known as division algorithm. Both mean the same. Algorithm in sense, it is a step-by-step procedure given to a system to work out the task. Here I have taken two numbers 18 and 762. How to compute GCD by using this algorithm. So by division algorithm or this algorithm, we know that our A dividend is equal to divisor into some quotient plus remainder, so that the range of the remainder will be more than or equal to 0 and less than divisor. This indicates that dividend is equal to divisor into quotient plus remainder. It is general way to understand division algorithm or Euclidean algorithm. Now always remember that left side number should be the dividend. It will be more than divisor. Out of these two, 762. So because it's algorithm, we have to proceed like this. Step 1. We write larger number dividend 762 is equal to, I am going to use here empty brackets to make you clear how the algorithm runs. One more bracket, because A is equal to B into Q plus R. The second bracket you designate by Q1, first quotient, and the last bracket remainder 1. And this is the bracket for divisor. Out of these two, the smaller one is 18. Now we have to see that what is the largest number we can take here, so that we can get a number very close to 762, not crossing this value. The excess value will be the remainder there. So by using our calculator, we can justify that very simply. I am using this scientific calculator, which is very much useful to compute GCD. In examination also it is permitted, not the application installed in our cell phone, Casio FX991 ES model. So here what I am going to do is just 762 divided by 18. I am doing 42. That is 18 into 42. It is 756 as I see here. 42 times, if you multiply 18, we are going to get 756. This value, we get 756. What I told you, you select a number here, a positive number, so that on multiplying these two, we are going to get a number not exceeding this dividend. So 18 into 42, we are going to get 756, very close to this one. So the leftover value is 6. 756 plus 6, we get 762. The remainder is leftover number. That is step 1. Now in next step, step 2, what is to be done? Be careful. Whatever the number you are finding before Q1, it is 18. So in this algorithm, the process is that divisor becomes the dividend remainder becomes the divisor. That is the idea we are going to find here. Whatever the number you are finding before Q1, here it is 18. So in next step, the dividend is 18 is equal to, again you give empty bracket, 3 empty brackets, and just you see the slant position. In this position, 8 is going to come. Here, the remainder, whatever left, that is going to come. In next stage, it is second quotient, second remainder. Now, very simple. 6 into 3, 18. No remainder, 0. Once you get remainder 0, stop. So, you move from down to top direction in the remainder column. The first non-zero remainder, whatever you are going to see, that is your GCD. That is your GCD. The first non-zero remainder from down to top. Once you get remainder 0, the immediate remainder which is non-zero, which is positive, that is 6. So in 2 steps we got the result here. So we can conclude this one as the GCD of 18, 762 is equal to 6. This way, that depends on the numbers, the steps are going to increase. Next, one more example I am going to explain you, so that the number of steps will be more than 2 based on the numbers. Hope it is very clear to you. Let us see the second example, the same as how to perform GCD using the same algorithm. Let us see one more example on finding GCD by using this division algorithm. Let us consider larger numbers. Find the GCD of 276 and 86421. This time I have selected a larger numbers. Generally, such when larger numbers are there, how to compute GCD. As I told you, the same idea. I am going to highlight that division algorithm, how to remember. That is, A dividend is equal to B into Q plus R, so that the range of the remainder will be from 0 less than B. It can take 0 up to a value less than B. B is a divisor. So step 1, larger number is 8, 6, 4, 2, 1. As I told you, give 2 empty brackets with product sign plus one more bracket for remainder. Let us indicate this one as Q1, first quotient, first remainder. The divisor is 276. Now what I told you, we first you take a calculator, it will save time instead of doing manually. So what I will do, first what number you have to take here, so that we get a close number to this value 86421. So what you must do, 86421, if you divide by that value 276, it is going to give you 313 approximately with some value. So I'll write here 313. Now if you multiply these two, first step is very crucial. You take 313 into 276. We got a value close to the 8638. You see, very close to this value. If you subtract this value from the original value on left hand side, 86421, we are going to get remainder as 33. If you subtract this value from this, we are going to get the remainder value 33. In step 2, what is to be done? Same. In place of dividend, this divisor come into picture, 276, the number before Q1. Again, you take a product of 2 brackets. Here also one bracket for remainder. It is Q2, it is R2, second remainder. In place of divisor, the remainder going to come into same idea. We have to take a number here very close to 276, such that we are going to get remainder again. So what is to be done? Take 276, just divide Using calculator 33. It is showing a whole number 8 times roughly. 8. If you multiply these two, what you are going to get? That is 8 times 33. It is 264. You can check through calculator. Difference of these two is a remainder. Minus 276. We are going to get the remainder 12. Be careful with the values. Step 3. Again same. Before Q2, 33 is a new dividend. It is Q3, third quotient, third remainder. Here we get 12. 12 how many times will go? 12 to 24. 12 36, it exceeds. 12 2 times it is 24. 33 minus 24, 9. Step 4, still it goes on. Here 12, number before Q3, R4, Q4. Here the number before Q3, 9. Here we get in place of this 9. Obviously only one time. 9 ones 9. 12 minus 9 is 3 the remainder. Step 5. Here 9. Here we get 3. It is R5, Q5. 3 times will go exactly. Remainder 0. Stop. Once you get remainder 0, stop. You move from down to top direction. The first non-zero remainder, whatever it is there, above 0, that is your GCD of those two numbers. So what is the conclusion? Therefore, our GCD of the given numbers 276 and 86421 must be 3. So 3 is the highest number that can divide both of these two numbers. Hope this example is clear to you all. Like that, any numbers if it is given to you, you can compute GCD by taking 2 the same manner. Next video we will see how to express GCD as a linear combination of two integers given to you. Do share our videos to your friends and tell them to subscribe and like, because learning never stops. You're teaching, right?